Hello, everyone. This time we're going to talk about eclipse. There are two kinds. There are lunar eclipses and solar eclipses. Both of them are two of the most amazing and fabulous things you will ever see in astronomy. And I hope in your lifetime you get a chance to see both. And if you're lucky, many of both. So what actually is an eclipse? Well, an eclipse occurs when one object is obscured by the body of another. So one object passes between you, the observer, and the thing you are looking at. Actually, another term that you're going to hear sometimes is the term occultation. And when something is occulted, just like the term occult that you might hear around Halloween, occultation is when an object moves between. So actually a solar eclipse is more precisely an occultation, because in a solar eclipse, here is the Earth, and here is the moon, and then the sun actually travels directly in the situation where it is obscured completely by the moon. And so the sun is occulted by the moon. So it hides behind the moon. But even full-blown astronomers who do this for a full-time job will call both solar and lunar eclipses, because an eclipse is when the shadow of one object goes and hides another. So in reality, the lunar eclipse is more precisely an eclipse, and the solar eclipse is more precisely an occultation. But like I said, even the big boys and girls who do this for a living call them both an eclipse. So what's going on in a lunar eclipse? Well, in a lunar eclipse, here's what we've got. We have our beautiful, fabulous sun. We have our Earth. And as you and I know, the moon orbits around our beautiful Earth. Well, as this occurs, sometimes, depending upon where you happen to be sitting on planet Earth, just due to the geometry of the situation, as the moon moves around, sometimes it happens to go exactly through and into the shadow of the Earth. And that is a lunar eclipse. When the moon in its normal orbit around the Earth does not pass through the shadow, we do not see a lunar eclipse. And that is a majority of the time. But when the geometry is exactly right, and the moon during its normal circling of the Earth, rotations around the Earth, actually happens to go through the Earth's shadow, then we get a lunar eclipse. Now, in any shadow, there are two parts. There is a very, very dark part of the shadow, and there is a not so dark part of a shadow. Next time you're outside on a summer day, see if you can find these two parts of your very own shadow. The darkest, innermost part of a shadow is called the umbra. So this is the umbra of this shadow of an object with light shining on it. And then the not quite so dark part of the shadow is called the penumbra. And during a lunar eclipse, the moon is going to go through the umbra and the penumbra of the Earth. And because of that, the lunar eclipses, the moon is going to go through some beautiful changes of how it looks during its travels through this lunar eclipse. So as the moon goes through its travels, as it starts to go through into the penumbra of the Earth, that outer weaker shadow of the Earth, it is going to go from being very, very bright to being a little bit dimmer. And as it gets deeper and deeper and deeper into the shadows of the Earth, it is going to become more and more and more blocked, because remember, the moon is an illuminated object. It doesn't emit its own light, just emits reflected light, and it is illuminated by our glorious sun. And so when it goes into the shadows, it's going to get darker and darker and darker and darker. And it gets so far into the shadows that it almost appears to go away completely. And then a wild and crazy thing happens. When it actually gets into the umbra, the deepest part of the Earth's shadow, it actually starts looking to be red. And we'll explain in a few minutes in the next slide, where does that red color come from? But then in this umbra, it has this beautiful red color. And as it emerges out the other side, it is going to go through that penumbra again. It is going to lighten, and as it gets lighter and lighter and lighter, and then eventually it will look back into its normal moon kind of a color and shine as it goes back into its regular orbit around our Earth. A lunar eclipse can last hours. It's a fabulous event. My husband and I have spent some wonderful evenings just hanging out on our back porch looking at lunar eclipses, and they are slow. They're fun to look at because you can chat and enjoy a bottle of your favorite beverage while you are enjoying them, because they take their sweet time. And they always occur when the moon is full. So you get to see that beautiful, beautiful full moon as it goes through these changes. Now, during this lunar eclipse, you're going to get this red color. So where does this red color come from? It is due to something called refraction. Refraction is the bending of light when it goes into a different material. Refraction is what occurs in the lenses of your eye when light comes in and allows your eye to focus things on your retina. Refraction is what takes light through a prism and breaks light into a rainbow. But what happens is this: the beautiful sunlight that comes from our glorious sun, our Earth is surrounded by atmosphere. And as that sunlight goes through the gases that surround our planet, two things happen. One, the light is refracted. It is bent by the Earth's atmosphere. And the light is scattered. Now, the scattered light is what gives us our blue sky, our beautiful blue sky. So the bluish wavelengths come down to Earth, and we look straight up and we go, we have a beautiful blue sky. And we'll go into this in more depth in a future chapter. But so some of those blues and greens get scattered out. The red colors get bent down and around the Earth. So it's wild and crazy, but it's due to changing from a vacuum of space into the air around the Earth that the light actually goes and it gets bent. And that bent light changes its path. Light, as you know, one of the properties of all electromagnetic waves is they travel in lovely straight lines. Well, that's true until they hit a new or different material. Then they can be bent, and that bending of electromagnetic waves is called refraction. So when they hit the Earth's atmosphere, they are bent downward, and they can be bent towards the moon. And that's what gives us that beautiful red color of a lunar eclipse. That bending of light down towards the surface of the Earth is also what gives us beautiful red sunrises and sunsets. Normally, if we had no atmosphere, sunrise and sunset, when the sun would go down, it would go, it would be black. Sunrises and sunsets on the moon without an atmosphere are just black. It goes from bright to dark immediately. But with a beautiful atmosphere, you get light bending around the planet a little bit, and you get this wonderful red color. This is a beautiful video I'm going to ask you to watch about to actually see a lunar eclipse in action. But one of the questions I get very often from students is, okay, if it's just a matter of we have the sun and we have the Earth and we have the moon over here, why don't we have a lunar eclipse every single month? Because that's kind of the alignment as the moon goes around the Earth. Shouldn't we have one of these all the time? Well, it has to do with the geometry. And the geometry of the thing is that all three of these bodies aren't perfectly on a straight line. We're not all on the plane of the ecliptic. The Earth and the sun are, because that's how we define the plane of the ecliptic. But the moon's orbit is actually about 5 degrees off. So the moon is tilted just a squidge, just a tiny little bit, 5 degrees off from the orbit of the Earth and the sun. So in order for it to be perfectly aligned with the Earth and the sun, it has to be a very, very specific geometry, and it's going to change depending upon where you and I are on planet Earth. So we get a lunar eclipse about 7 times per year. Very often these are going to be partial eclipses. And where these lunar eclipses are, they're going to change. So sometimes they're going to be North America. Sometimes they're going to be in the South Pacific, where there's just a few small islands. Sometimes they're going to be in Siberia or southern South America. And these will change from place to place depending upon the geometry. So when are the next lunar eclipses? I'm going to ask you to take a look at this website. They update it all the time, and it will list when the next lunar and solar eclipses are, because it's really fun to keep an eye out for them and make sure that you are watching them. All right, that is going to do it for this time. And then next time, we're going to talk about solar eclipses. See you then.